I'm one of the clinical professors in the Applied Data Science Master's Program. I've taught here for a few years. Long ago, it feels I was even a student in this program. And I've been a student at the university twice more besides that. I love the University of Chicago. I love data science. I've worked in industry for about 14 years before going full-time teaching at the beginning of last year. And my industry experiences have certainly, grown me along the way. I've certainly benefited from just being around a bunch of other smart people, a bunch of challenging data science work. I'd like to share a look at some of that with you today. My understanding is most of you are thinking about a master's degree program in data science. And I'd love to give you a look at some of the realities of data science work on the job. This is the sort of thing that a textbook is not going to do a great job of teaching you. As much as I love teaching from textbooks, this is about the practice of data science and a look at what a life or a career in data science might involve. So let's get started. The theme today is database decisions in the limits of knowledge. It's always tough to come up with the hottest take in the room, and I generally try to avoid that impulse to say something controversial for the sake of controversy. But today I do want to tell you some lessons I've learned along the way that do seem to fly in the face of why people get excited about data science or what they think a data science project could achieve. I'm not doing this to knock down anybody's vision. I actually find some joy in the complexity and the nuance of data science. It's not always as straightforward as you might think. And so I would like to share a case study with you of a large, complex data science project that could be used to explain some of my thoughts about what we do. Before I go any further, I do want to say that this is work I did with a previous employer, Civis Analytics. Although I led the work, I cannot say this is my own work. I did it as an employee of that consulting company. I'm proud of it. This work is a matter of public record. It's not like I'm telling you anything super secret or anything like that. It was nominated for an award, I believe. But I will, in some cases, sort of glide past the name of the client particularly, and I'm not going to be sharing exactly the specific findings or any work product. I'm going to be talking more in generalities, which is okay on my part. I love that because what I'd like to do is use this project not to tell you about a success story, but to illustrate some general challenges and general trends in our field. Let's get started. I have a few quotes to sort of motivate us on our journey here together. One of them is from an econometrics textbook written by Peter Kennedy. He says, "Economists' search for truth has, over the years, given rise to the view that economists are people searching in a dark room for a non-existent black cat. Econometricians are regularly accused of finding one." Before we dive into that, I'll just pair it with a second quote. This is from Steven Weinberg, a Nobel laureate and a former director of Oak Ridge, I think, National Laboratory, where I worked one summer long ago. He said, "The effort to understand the universe is one of the very few things which lifts human life a little above the level of farce and gives it some of the grace of tragedy." And I could not agree more. We data scientists want to understand the universe. It's a noble pursuit, but life without seeking understanding is just farce. It's comedy. It is absurdism. But seeking truth, oh boy, it's a difficult path to tread. The grace of tragedy is what we're about here today. So I'd like to outline a problem around the 2020 decennial census conducted here in the United States. Then I want to explain the problem with that problem, why it's not as straightforward as it sounds. And I want to end by giving you some tips for your own projects, your own careers, about how to move forward through challenges, through uncertainty. And last, I have a little bit of acknowledgments, and there may be time for some questions and answers. So, what's this project about? The decennial census. I have to briefly bring you into the census world, make you all, if not census experts, at least census journeymen for a moment. In the United States, we hold a census every 10 years. A census is not a survey. A census actually tries to count everybody instead of getting the opinions or of a representative sample of people. A census is a difficult thing. I don't know if we would normally do a census, except that it is actually required by the Constitution. It's right there in Article 1. Way back when the country was founded, it called for a census to be conducted every 10 years. And we've done it every 10 years since 1790. The census is enormously important to our civic life. Some of you may know that the population of each of the 50 states is used to apportion the electoral college votes. So in the United States, president is not chosen based off of the proportion of the popular vote that they won, but rather each state has a certain number of votes in an electoral college, and the popular vote within each state decides how those votes get split. Population is also used for congressional redistricting every 10 years. That's enormously important to your voice, your ability to be heard by your representatives. And also about $3 trillion per year in federal funding to local governments flows down partly based off of census inputs. There are many sort of large federal projects, large federal vats of funding that get distributed to cities and towns and counties based off of things like the average income in those places or the population in those places. Those are things tracked by the census. Finally, the census is the gold standard by which a lot of public and private research assets take their weights, take their baselines, their benchmarks. Many, both firmographic info, demographic info, all sorts of data sets that are out there to sort of track how things are doing in the United States, use the census figures to do things like normalize for changes in population or reweight according to certain demographic standards. So the census is an enormously valuable tool, and you would be right in suspecting it should be as accurate as we can make it. So why would the census not be accurate? Well, counting everybody is hard. It used to be until 1960 that the Census Bureau would send people around door to door to door to count everybody in the country. They still do a little bit of that work, but since 1960, the primary way that we gain information during the census is to mail out forms to every household in the United States and ask the people in that household to describe their household and mail the form back to the Census Bureau. That turns out to be a very accurate way of doing things. People don't tend to lie about themselves because there's no immediate benefit to them for lying. They mostly tend to describe themselves and the other people in their household as accurately as they can. And so the census far prefers that we do that than any other method. If nobody mails a form back, they will send somebody around to knock on your door. If nobody answers, they will send somebody around again. If still they can't get in touch with you, they might ask your neighbors about you. They might rely on administrative records, things like, oh, I don't know, public utility information about who's paying for the electricity in your home, things like that. And then finally, if they can't have any other information about you, households are imputed. That is, they're sort of statistically inferred from a variety of other records and data sources. If that sounds a bit sketchy to you, it is. It's an error-prone process, imputation or administrative records. So for everybody to be counted accurately, the best way to get that done is just to have people respond to the mailers sent out by the Census Bureau. One principle in data science is that missingness in your data is almost never at random. This is also true for the census. If they can't find people, those people are not evenly distributed throughout the population. I don't want to make race and ethnicity the only lens that you can apply to this situation, because there are many others: rural, urban, income levels, internet connectivity. But just to use race and ethnicity as one lens on the problem, you can see here, this is real data from the 2010 census, the past cycle before this last one, that shows that, for example, non-Hispanic Black individuals in the United States were undercounted by about 2%, while non-Hispanic white individuals in the United States were actually double counted or overcounted by nearly 1%. When you tie the fact that these counts are also what are used to create apportionment of electoral college votes in redistricting in Congress, in federal funding to the local governments, the fact that there's differences in who gets counted and how well along lines such as race or ethnicity, income levels, language spoken, the fact that there are these differences creates inequality, creates inequity. It creates bad outcomes or re-entrenches some of society's existing bad outcomes. So many groups are concerned about this. Many groups want to make this better. In 2020, things looked particularly challenging. It's always hard to count everybody in the country. There's always going to be inequality or bias, systemic challenges to face that we need to push through to get the best count possible. But 2020 was even harder than usual. The federal government, the Trump administration at the time, did a lot to suddenly remove funding from the Census Bureau in ways that outside observers felt were at least as politically motivated as it was sort of simple cost-saving measures. New techniques were going to be introduced for the first time to use statistical imputation to infer households when they could not be counted. These techniques seemed more error-prone than usual, or they seemed at least to have the capacity for greater error rates, and had never been tried before, which made some census watchers a little nervous about that. There was historically low trust in the federal government. If you're mailing things as the federal government to all us residents and asking us to fill out information and send it back, it's a bad thing when trust erodes. People worry about how the government might use that information. People might not want the government to have anything from them, to have any more information about them. And we residents of the United States are historically less visible to the federal government. We move around more. We're not using landlines as much. Our method of contact, our email addresses or our phone numbers change more often. It's harder to find us than it ever was. You might remember, if you were watching the political space in 2020, that for a while, the Census Bureau planned to have a question on the census about the sort of legal residency status or the citizenship of the people in each household. That citizenship question was immensely controversial. And I believe it had to be struck down by courts. It had to get the judicial branch involved to remove it from the form. But sometimes once you make a breach of faith, people remain wary even after that breach is repaired. And people, census watchers, worried about the effect of this citizenship question. Then, of course, COVID-19. For 2020, if the Census Bureau was planning in the summer of 2020 to send people door to door across the entire country to meet strangers and talk to them, well, you can imagine that a global pandemic vastly complicates this problem. Who will open the door for the stranger? And how can you get volunteers or low or even paid individuals to suddenly take on a job that could be risking their own health and safety? So many challenges in 2020. I've got one news story up here, but the more you search, the more news stories you can find, all saying the same thing, that 2020 presented unique challenges. Okay, so that's where our client and my former firm stepped in. We had a nonprofit organization reach out. It was one of many nonprofit or local governments that were concerned about how things were looking, how things were going, and wanted to do what it could to ensure the most accurate count. In this case, the client had a small amount of funding, essentially, that they wanted to put in as efficient a method as possible. Everybody has limited resources. Every client organization, every employer you'll have has limited resources with which to solve their problems. They often have to not completely solve a problem, but simply try to place those resources in a way that will help their money or time or energy or employees create the most effect possible. So the client here was hoping to understand in which states an undercount would have the greatest bad effect, deleterious effect on democracy, whether that be redistricting, apportionment of electoral college votes, or federal funding. And within those states, to do what they could to ensure that certain thresholds of sort of change or unrepresentative effects on democracy would not be felt. That's a tough order. That's a very strong challenge here. And so, for example, the data here don't correspond to anything real that we were calculating, but you can imagine that we would look at every state. We might decide upon Connecticut as a place where there was a dire need, a dire risk of an undercount, and try to quantify that in terms of a change in federal funding or a likelihood of losing electoral college votes. That's not to say that we were against the idea that any state would lose funding or lose electoral college votes. That's a natural part of the process. That's why we have a census, to rebalance funding, to rebalance the electoral college votes. But we don't want any state to lose more than they should based off of the honest changes in population. There were all sorts of tools that we built in-house, tools that we leveraged that other people had built, where you can zoom in, not at a state level or a county level or even a city level, but down to individual census tracts. The US Census splits the whole country up into thousands of small parcels of land, less than the size of a neighborhood usually. In a dense city center, a census tract might only be a few blocks. They generally have between 2,000 and 10,000 people in them. And so at a tract level, you can go in and think about who lives in these tracts, how likely they are to respond to the census, what dangers there are about the people in those tracts being not counted or undercounted by the Census Bureau. What I'm getting at here is that this is a data science challenge. It's not just a problem of rhetoric. It's not a problem of lobbying. It's not persuasion, although of course persuasion plays a part. There's a lot of data here, a lot of very granular demographic data. And you would hope that talented data scientists could make a difference. So I don't know about you, but I've listened to a lot of people start a presentation of their data science project. And after a while, you start noticing a lot of common elements, common arcs to the narrative. And at this point, based off what I've shared, I wouldn't be surprised if you were thinking of those same narrative arcs. And I would start by saying, okay, well, we're going to estimate the undercount in each state. We will select the most critical states and examine them at a more local level. Work with, for example, an ad agency to create public service announcements, helping induce people to fill out their census forms, run those ads in the places where they are most needed, save the world, ice cream and pizza for everybody, job well done. That's what we'd like to believe that you can do with data science. But that's not the theme of my presentation here today. So that brings me to the second topic, the second phase of this presentation, the problem with the problem. To get that there, I want to share one or two more quotes with you. This one was from somebody who was my manager at the time, but had been a branch chief at the Census Bureau, which is extremely lucky for me. I'll talk about that later. He said that if you could accurately predict how the population had changed from the historical data in past censuses, there would be no need to conduct a census. I've heard this put another way, perhaps more simply, that the census's job is to surprise us. That is the point of conducting a census. The nation changes in ways that we cannot easily foresee based off of what we last counted 10 years ago. If we could easily foresee it, we wouldn't need to run a census every 10 years. The census, seeing things we did not expect, means that the census is behaving as intended in a way. So while you noodle on that, the other thing I want to ask is to mirror a question asked by the New York Times in an article written around this point in time. What happens when the gold standard turns bronze? If the census is the gold standard by which all demographic data in the United States is judged, how do you measure how bad the gold standard is? There's no more gold data set. There's no data set out there that is considered better than the census by which we can measure how bad the census is. So here's one of the biggest challenges. How do you count the number of people who won't be counted in the census before they're not counted? Because that's where we were. We were sitting there in 2019 trying to learn who wouldn't be counted and then to get them to volunteer a response to the census, or at least be counted by the non-response follow-up teams. How do you count the number of people who won't be counted? We know that the true population in the United States is equal to the counted population plus the uncounted population. That's just algebra. It's hard to estimate any of these directly, though. How could you make a running start at knowing the true population of the United States? That's why we have a census. Nobody knows the true population. We need to have a census. And why would my guess or my company's guess or any private research team's guess be better than that of a massive federal agency dedicated towards exactly this question? Where would you even go to learn or estimate or forecast this true population? All of the projections out there pretty much start from a basis of the 2010 census. And the 2010 census is now out of date. That's why we're conducting the 2020 census. And as somebody not working within the federal government or a local government, I don't have access to the sort of administrative records that could be used to create an alternative estimate. For example, in addition to the decennial census, the Census Bureau has an alternate way of estimating the US population, which is kind of almost terrifyingly simple in a way. Starting from around 1920 or so, they have just added up every birth recorded by every hospital. They've added up every death recorded by every county medical examiner. They've added every immigration record from Ellis Island and all the border crossings. And they've subtracted away all the people who have left the country from those same border crossings. And that's a largely independent source, and it can be an interesting check on a census. But I don't have access to that information as a private researcher. Okay, well, if I don't know that, can I at least estimate the counted population? Maybe, maybe. I mean, if I've just detailed for you a page full of unique risks, things that are different this cycle than in previous cycles, then probably I can't look at the previous cycles as a way of understanding the world. I'll have to, I need to move forward without being able to rely on the past to inform the present. And remember, all this has to be done ahead of time, which means I don't even have a way of validating. I forget a test and train data set, right? I can't split my data up and compare my out of sample versus in sample prediction errors or any of the tools that we might normally use because we don't have the truth yet. I don't have a training data set for this. As far as the uncounted population, well, the census will run a study on that, but in 2019, that was not available to me or my team. That wouldn't happen until 2022. And so there's no way to know ahead of time what this uncounted population looks like. I gave you some demographics in an earlier slide showing how certain groups of people were overcounted or undercounted. But those proportions change in every cycle because the census does try to solve its own problems. The census does try, census to census, to do a better job and redistribute resources or try different methods of getting to people. So I can't count very easily, at least, the number of people who won't be counted. I can't define how bad this problem is. Maybe that was a lot of detail. Maybe I'm too deep in the weeds. Let me back up a second and put it in very simple terms. Everybody feared an undercount. Okay, what happens when there is a census and the total population estimated by our census is lower than we expected? Some people might say, yeah, we feared an undercount and this number is now lower than we expected. But maybe our expectations just weren't very good. How can we choose? How do we know which world we live in? We won't. Okay, a second problem with the problem. How do you measure the value that you are going to add to this process? How can you talk to people and say, this is what we can do? This is how we can help? Our value is how many more people are counted because we went to work versus how many people would have been counted if we hadn't done anything. Those are also very difficult to estimate directly. So you want to be able to tell people what you were doing, how you could help, sell to people the value of your services, or even just say afterwards, if somebody's paid a large amount of money to help make this problem better, you want to tell that person or persons or company, here's what we were able to do with your resources. But these two things cannot be easily estimated. I'm going to skip through this slide a little faster. I'm not going to go through all the bullet points individually. But I will say that you, in advance of the census or even after the census, you're not going to be able to say, we got this many people counted. You don't have that information. It's very reasonable, it's very understandable that the government does not give you individual level information on who's being counted in real time. That would be a severe breach of privacy. And so you can't even really understand, what this problem would have been if you hadn't done anything. That's constructing the but-for world, as it's called, is near impossible here. Again, for those who have kind of tuned out because I've been geeking out over these details, the simplest way to put it, I know how, is I'm trying to measure my value. What happens if I believe that I've added value because the count in an area where I spent my time and energy was higher than I expected? But how can I tell the difference between that being due to my efforts and whether my my estimates just weren't very good. All right. So where are we? It's 2019. The team that I've assembled, the client organization and its partners are all hoping to make a difference. And we come to the conclusion that we don't know if there is a problem. We won't be able to measure it very well. And we won't be able to measure if our work has done anything to solve the problem. I want to say that this is a really common experience. Most projects are somewhere in this ballpark. It's difficult to know the size of the problem, and it's difficult to know if you've solved it. The census posed unique difficulties. It really made it hard to get even a credible estimate of some of the numbers that we needed as inputs. But all of the work that you might do in your careers, you'll be struggling against these same concerns. How do I know how bad the problem is, and how do I know that I've fixed it? Well, I do have some advice. I do have some general principles which might help you. Uh, Here in the program, you'll be able to listen to a lot of professors or guest lecturers talk about the lessons they've learned. This is just a few of them, and it won't always work for every one of you, but maybe it'll at least start you thinking about these ways forward. How do you move forward through that fog of uncertainty? All those challenges, it can be so daunting. It can really make us say, maybe it would be better if I don't even try. Why try if I can't understand the problem and I won't know if I've solved it? My first lesson or piece of advice is to prepare for the world that needs your help. And I mean this as both a project management tip and a career advice. As a project management tip, what I mean by that is we didn't know whether there was a problem, but we had somebody whose resources were there for us to use to help solve the problem. So it behooved us to let us assume that there is going to be a problem and move forward from there. If there's no problem, great, great. What's the harm, right? Why we're going to try to help democratic causes here, not democratic as in the political party, but the idea that the people's voice should be heard. So if the world doesn't need our help, great. But if it does, we'll be there when it needs us. We could come up with many different scenarios. We could plot severe outcomes versus mild outcomes. We could bring this to our clients and say, all right, we don't know exactly what the real 2020 world looks like, but here's what it would look like, we think, if there is a problem, if there will be an undercount. If we make that assumption, this is the way that it would go down to the best of our knowledge. More generally, as career advice, I mean that you're going to build certain skills. You're going to position yourself within certain organizations, governments, companies, think tanks, universities. Make yourself into the tool that will be useful if there's an emergency, if there's a problem. If we happen to live in a world where no emergencies ever happen again, no problems are ever encountered again, wonderful. I won't regret the time I spent getting good at solving problems. But if you can fashion yourself into a solution, waiting for other people to say, yes, there is a problem, now we need that solution, that's going to reap returns for you in a professional sense. When putting together this slide, I thought of Blaise Pascal, the mathematician, rhetorician, philosopher, savant, who described what he called Pascal's wager, where he said, well, I don't know if there is an afterlife. I don't know if there's an omnipotent God or not. But it seems to me that we should all try to believe that there is, because if I believe there's a God and there's no God, well, there's nothing wrong. Nothing occurs to me. But if I fail to believe and there actually was a God, well, very strong positive or negative results might happen. I'm not advocating you use this in your own spiritual journeys, but I think of Pascal's wager a lot in terms of, what are the asymmetric costs of being right or wrong if there is a problem or opportunity, or if there's not a problem or opportunity. Sometimes it is better to prepare for the world in which we're needed. Lesson 2, you really can't do anything very well through data alone. There's such a tendency to think that if all you have is a hammer, then the world is full of nails, right? As a data scientist, you're going to learn a lot of techniques, and you won't be gaining a lot of expertise in psychology or public policy or sociology or manufacturing. We can only teach you one degree at a time, essentially. And so people believe that because they have this set of skills and they wish themselves to be valuable to other people, they're like, oh, okay, well, problems could be solved by just my set of skills alone. I can solve real problems alone by myself with these new skills I've developed. You can be part of a team that solves problems. You can contribute meaningfully as long as you talk to those other subject matter experts. Talking with people, understanding this world that created the challenge, it's absolutely vital. You cannot study things from the confines of your home office and gain an understanding of how they actually fit together. There are so many people to talk to, so many expertises to draw upon. With something like the census, it's particularly difficult because the census only happens every 10 years. So it's very hard to find people who have real experience running or participating in multiple census iterations. But they are there and should be talked to. Talking to humans is important for a variety of reasons, of course, but one of them is a data scientist by themselves can solve a problem, but they don't necessarily know which of the several problems to solve they should be working on. There are trade-offs between, for example, efficiency and equity. That's one we see in the census. Do we try to get the most people counted, or do we try to focus on people belonging to classes that we think are particularly likely to be undercounted? Which of those is the right way forward? That's an ethical question that deserves to be answered by many voices in a community, and also in cases when you work with a paying client, the client themselves. If you thought I was getting nerdy for referencing Blaise Pascal earlier, I'm about to one-up myself, and I don't say that with pride. Ludwig Wittgenstein, in the Tractatus Logico-Philosophicus, wrote, "Whereof we cannot speak, thereof we must be silent." And I think that the data science version of this is, whereof the data cannot speak, thereof we must listen to humans. I won't quit my day job, but please know that the data don't speak to every challenge. The data don't have a full answer to every priority or aim you could have. You need to talk to humans to learn these things. All right. Lesson 3, iterate. Lesson 4, iterate better. Our big challenge with the census was that we only had one shot. It was going to happen. Everyone would be counted once. We can't study that and then do better the next time, because there is no next time. Not a 2020 census next time. There'll be a 2030 census with its own challenges. One way through this is to break it down into small pieces. We actually were able to get daily information from the Census Bureau of the number of people who had responded in every census tract. And we could run pseudo experiments. We could push messages to people within certain areas in a town. I'm using Hartford, Connecticut here. That's not one of the places we did our work. It's an almost distressingly easy place to count people. But you could imagine thinking of all of the census tracts here and seeing the rate at which they respond changing day by day by day. Then you could identify some of these corners of the city, push public service announcements to phones and laptops and just through paid internet ads, essentially, in these areas, track the change in census returns, and compare them against other areas in the city that you've picked to be similar in certain ways where you're not running the ads. It's not a full, proper experimental design, but it gets very close and gets close to providing a causal estimate of the effect of your work while the census is happening. Iteration is a stressful thing. You have to move nimbly, you have to move fast. You have to keep reporting back and learning and changing. And it's stressful partly because it allows us to measure our own failure. It allows us to see in real time that we are not having the effect that we want to have. That's also its greatest value. Knowing that you can change course because what you're doing isn't working and adopt new strategies and measure how well the new strategies do, that is why we want to iterate. That is why it's worth picking this method that involves a lot of extra work for some people and a lot of stress for others. Iteration also allows you to get good at something. If you only do something once, you're likely not doing it very well. But if you can build a model in which you try the same task many times, you improve at it. Your processes improve. Your ability to perceive small differences or to do better at it improves. You build more trust with the people you're working with. Iterate whenever you can. Right. My last lesson here is remain aware of the limits of your knowledge, your reach, and your understanding of the other actors involved in the situation. I'm not going to go into sort of the results of our analysis and the project conclusion. What I will leave you with is this table, which was generated in a 2022 report, 2 years after the census, where the census does its own quality control survey or estimation study. We're not going to have to go through this number by number, but you can see here that between categories of race and ethnicity, the Census Bureau is estimating how it overcounted or undercounted people in 2020 versus 2010. This is not my conclusion. This is not my former employer's conclusion. This is the census's own look at itself. And it finds that really in 2020, people were right to be worried. Classes of people in this country already underserved and underprivileged, Black Americans, Hispanic Americans, American Indians, were counted at worse rates in 2020 than in 2010. For example, you can see here that American Indians or Alaska Natives on a reservation were undercounted by more than 5% in 2020. It's a hard population to count, yes, but that doesn't mean that that's not important to do well. And the 6.4% in 2020 was worse than the 4.88% in 2010. You can see that for a number of categories here. So where does that leave us? Did the project I worked on succeed? Did we save democracy? As I've explained, it's hard to tell. There were ways in which we measured differences. We thought that we had an effect on the margins. We could talk about it to the people who had hired us. We could tell that story to the public if we so chose. But at the time, it was difficult to know. And it was only 2 years after the fact that we're even able to validate that there had been a problem in the first place. There are real limits to our knowledge. There are real limits to our ability to change the world. Data alone won't do it. Partnership, understanding, communication. Those are requirements to even have a shot at creating change. So this may sound perhaps a little dismal. That's not my intent. I think that working together with other humans communicating, understanding them, using data appropriately as opposed to relying it as the crutch with which we will solve all evils and remove all obstacles, is the only way that we will get stuff done. And it excites me when we have opportunities to do that. It excites me to tackle hard problems and have a shot at having a small effect, because I know that usually we don't even have that. I love that data science has given me tools with which I can study these things and begin, as Steven Weinberg said, to move beyond farce and into the grace of tragedy. I want to finish up quickly here, hopefully with time for one or two questions before I have to drop for my own class. First, I need some acknowledgments. I want to reiterate, this is not my own work as an individual. I was part of a team. I was leading that work, but it could only have been done with the help of many others, including my manager and folks who worked with me on the team. I'm just picking out a few people here to highlight because I want you to really think of them as representing larger categories of people. Chris Dick, my manager, could be a bit of metonymy for the larger civis analytics organization that allowed me to do this kind of work. Iñaki was not the only person on my team, but he's an example of somebody who was so helpful to me and who, you know, through projects like this, has now got the position I had at the time, right? I was a data science manager and he was my report. Now he's
right into a receiver's hands for.
I'm sorry, say that again, John. And I also want to highlight the invaluable efforts of many, many, many concerned census sort of watchdog groups, think tanks, experts. One of those people would be Denise Ross, who at the time was affiliated with an academic institution, but went on, and you know, this was just a few years ago, so went on to become the US Chief Data Scientist and is now the Deputy US Chief Technology Officer. Denise stayed in touch and even helped me prepare a little bit for this presentation, tracking down some details about past censuses that I sadly have realized I do not have the time to present to you, but the census is full of remarkable stories. All right, so I teach class at 6. I won't have time to address all the questions. I do see that there's a few questions in the chat, so I want to take a look at them. Brittany, yes, the census had an online response option in 2020. It was the first time it was used, but I support its use. I don't think that was hurting things. I think that was helping things. Although all tools have disparate impacts, internet connectivity is not equal across the country. I think we are moving away from landlines and knocking on doors, and that's probably a good mode to add to the mix.
Yeah, I would agree it's good. And in the survey field in general, most projects are adding multiple modes because one just doesn't cut it anymore. But I was just curious too about how it impacted your ability to even make your predictions when there was yet another factor that was brand new in there.
I see a question also from Alexandria, and the question is about a technique that I've used often in other data science projects when you're trying to do forecasting. What you do is you use, if you have, say, 2015 through 2020, and you want to understand 2021, you build look-ahead models of all those past years, 2015 looking at 2016, 2016 looking at 2017. And you hope that by doing so, you gain some insights as to how your model predicting the unobserved 2021 year would look. That's not as useful with the census because of the degree of change decade to decade, and because the types of change seem to be new every decade. There really isn't a lot of belief that the same trends from 10 or 20 or 30 years ago, or even 5, to be frank, are going to be continued in this most recent few years. Marie has a question about sharing interim findings with stakeholders. Ours worked very closely with us. trust is very important here. I've been part of many vendor-client relations over the years on both sides of the equation where trust breaks down because people suspect that one side is just saying what they want you to hear, or they think that you want to have heard. So I don't have anything that can be usefully elucidated in just a couple minutes, but I would say that if you have a high degree of trust, then sharing bad news is not about your own failures. It's not seen as being about your own shortcomings. It's seen about a realistic look at the challenges in the world around you, and that bringing bad news can be viewed positively by people if they trust you. Kashesh asked if trends couldn't be picked up based off the current population. No, is the simple answer. I mean, at a broad level, you can talk about things like California and Texas will continue to gain population. People have an idea of what direction everything is headed. But for things like apportionment of electoral college votes or federal funding, the nuances, tiny, tiny proportions, whether the growth is 8% or 9%, makes a huge difference to some of these outcomes. The level of precision required is such that trends observed 10 years ago are not good enough to create a convincing picture of the present.
Great. Thank you, Jonathan. I know more questions are coming in, but I know you've got to run to class. So I just wanted to take the moment again and thank you for kicking off the data science seminar series. Have fun with statistical analysis. Again, thank you. And for those of you still on the call, let me pull up my form here. Let's see. Now this is where my technology ability falls.
Right. I'll
Yep.
sign off, but it was
Thanks,
great
Jonathan.
talking with all of you and sharing this story out.
Right. Thank you, Jonathan. Great. And so for those of you still on the call, we feel bad that Jonathan wasn't able to get to all the questions. And so if you still have questions, feel free to email that applied data science admissions at uchicago.edu. If we get the question by 10 a.m., we're going to try our best to answer all of them with a follow-up email when we will send out the recording to this event. So again, if you had a question that wasn't answered, or maybe you've been thinking about a question, feel free to email the applied data science admissions, and we'll do our best to get the question answered, hopefully, and then send the recording of the event. Also wanted you all to know, you'll be the first to know that our next session for the data science seminar series is November 11th, which is a Saturday, 10:30 a.m. to 11:30 a.m., where our instructor in the program, they're going to be looking at generative AI, both kind of going through the history of generative AI and where the field is moving towards as well. And so there'll be more information on the website relatively soon, but just wanted you all to be the first to know about the upcoming data science seminar series part 2. And then finally, I know some of the names I saw coming through in the registrants. You can go ahead and start your application if you're not already part of the program. I know we had some current students in the program already in the program participate today. But if you're looking to join this program, there's the application link. Just a reminder, the spring part-time online, those classes would start in March, and then all the other program offerings, including the part-time online, would start in the autumn quarter, which would be in September. So again, if you have any questions, of course, yes. So I'm glad to hear, and feel free to provide any feedback to apply data science admissions at uchicago.edu. We want this the data science seminar series to be a very collaborative, fun chance for people to quote unquote geek out. So if there's a particular talk that's maybe of interest that you want us to address, feel free. We can't promise that we'll get to everyone, but we want to hear your feedback. What would be helpful for you all to hear? What are you curious to hear? So take advantage of that. Feel free to email questions and email maybe potential topics of discussion to apply data science admissions at uchicago.edu. Thank you all for taking the time to join. I know here in Chicago, it's the end of the day. But I'll stay on the line for a couple more minutes, see if there's any questions. If not, feel free to sign off, and we look forward to seeing you at the next session.